We are given f double prime of x equals 4x plus 3, and f prime of negative 3 equals 4, and f of negative 3 equals 3. We're asked to find f prime of x and f of 3. Since we can think of integration as the opposite operation of differentiation, if we integrate the second derivative, we recover the first derivative plus a constant. And if we integrate the first derivative, we recover the original function plus a constant. To begin, we will integrate the second derivative to recover the first derivative, which gives us the integral of 4x plus 3, which is equal to the integral of 4x, or 4x to the first, which is 4 times x to the second divided by 2, plus the integral of 3, which is 3x plus c. Let's go ahead and simplify. 2 and 4 share a common factor of 2. There's 1, 2, and 2, and 2 2's and 4, which gives us 2x squared plus 3x plus c. And since we integrated the second derivative here, this is the first derivative plus a constant. So now we know f prime of x is equal to 2x squared plus 3x plus c. From here, since we know f prime of negative 3 equals 4, we can determine the specific value of c for our derivative function. Again, since f prime of negative 3 equals 4, if we substitute negative 3 for x into the derivative function, the function value must be 4, which gives us the equation 4 equals 2 times the square of negative 3 plus 3 times negative 3 plus c. And now we solve for c. We have 4 equals, the square of negative 3 is 9, 2 times 9 is 18. We have 18 minus 9 plus c. Simplifying, we have 4 equals 9 plus c. Subtracting 9 on both sides, we have c equals negative 5. So now we know the specific first derivative function is f prime of x equals 2x squared plus 3x, and since c is negative 5, we have minus 5. So this is one of the answers the question asks for. And now that we have the first derivative, we can begin recovering the original function by integrating the first derivative. So we have the integral of 2x squared plus 3x minus 5, which is equal to the integral of 2x squared, which is 2 times x to the third divided by 3, plus the integral of 3x, which is 3 times x squared divided by 2, minus the integral of 5, which is 5x, and then plus c. Which means we now know the original function f of x is equal to 2/3 x cubed plus 3/2 x squared minus 5x plus c. And now we can find the value of c because we know f of negative 3 equals 3. Since f of negative 3 is equal to 3, if we substitute negative 3 for x, the function value must be 3, which gives us the equation 3 equals 2/3 times the cube of negative 3 plus 3/2 times the square of negative 3 minus 5 times negative 3 plus c. Simplifying, we have 3 equals, let's simplify this right side on the calculator. On the right side of the equation, we have 10.5 plus c. Let's convert 10.5 to a fraction by pressing math, enter, enter, which is 21/2. So we have 3 equals 21/2 plus c, which means c is equal to 3 minus 21/2. C is equal to negative 15/2. Of course, we can check this on the calculator if we need to. 3 minus 21/2 is a negative 15/2. So now we know the original function f of x is f of x equals 2/3 x cubed plus 3/2 x squared minus 5x, and since c is negative 15/2, we have minus 15/2. So while we're not giving f of x as an answer, we do need to find f of x in order to determine the function value f of 3. f of 3 is equal to 2/3 times the cube of 3 plus 3/2 times the square of 3 minus 5 times 3 minus 15/2. Now we'll go back to the calculator one more time. F of 3 is equal to 9. I hope you found this helpful.